The radical hydrohalogenation reaction is a reaction of an alkene to form an alkyl halide in an anti-Markovnikov fashion. The first step is an initiation step where we break the oxygen-oxygen bond in a homolytic bond cleavage to form two hydroxyl radicals. These hydroxyl radicals can then react with the hydrogen in HBr, doing a hydrogen atom abstraction, forming a bond between oxygen and hydrogen, and breaking the HBr bond, putting an electron on Br to form our key propagating radical Br dot plus water as a byproduct. In the propagation sequence, we have our starting material react with Br dot. The Br dot is going to add across the alkene to do an alkene addition reaction. We're going to form a new bond with the less substituted side of the alkene. So carbon number 3 will form a bond with bromine. When we break the pi bond, the remaining electron goes onto the more substituted side as the most stable radical possible. In this example, that will put a new radical at carbon number 2 and a new carbon-bromine bond at carbon number 3. In this sense, this reaction is not all that different from a Markovnikov process. We get the most stable radical, but we put the bromine on the less substituted side. In the final propagation step, carbon dot forms a carbon-hydrogen bond with HBr. That bond breaks, the remaining electron goes onto bromine to form Br dot and form our major product, along with more Br dot. This completes the chain reaction of the radical sequence. There are termination steps. I'm not going to draw them here, but this is the radical hydrohalogenation mechanism.